Alright, so up until here, we've always been dealing with degrees, whether that's grade 9, 10, 11, well, up until right now, and probably earlier in your life, in grade, 1, 2, 3, 4, 5, 6, 7, 8, you've always been dealing with degrees. So, degree seems like a pretty fun and a pretty good measuring unit. However, we have other units as well. So the other units that we have is radians and revolutions. So revolution means you're going one revolution around the circle, one revolution around the circle. So one revolution is actually 360 degrees. So with that said, we also have the other one, which is radians. I'm not gonna. So a radian is actually one radian is actually equal to 180 degrees, and we will see how this plays out. So we're actually using most of the time we're using radians, and we're using a formula corresponding to radian. So a radian is the measure of an angle subtended at the center of a circle by an arc equal in length of the radius of the circle. So why do we invent the radians? I mean, we were all good with degrees and stuff. Why? So many calculations that you will find in university level mathematics, university level physics, you'll find that, hey, wait a minute, if I use radians, this is much more simpler. So essentially, people invented this radian unit so that we're now able to use this radian, and it will simplify calculations. So 1 radian, 2 radian, 3 radian. So notice how you calculate radian. It's r over r, 2r over r, 3r over r, right? However, let's see. What is 180? What is 180 degrees? If 180 degrees, how do we convert that into a radian? You look at it and be like, hey, wait a second. Wait a minute. Wait a minute. Hey, wait. This looks like it's something around 3 point something, right? It's 3 point something. It has to be 3 point something. So what exactly is that value? Well, it's pi. It actually is 3.1415, and all of that pi radians is equal to 180 degrees. Right? So this math is really precise here, and it's actually really interesting how it works out. So let's go ahead and introduce us to our first formula, which is pi over AR. Sorry. Theta is equal to arc length over radius. So we can actually go ahead and derive that from here. So you can see r over r gives us theta, r over r gives us theta, r over r gives us theta. So now we can actually go ahead and derive that from here. So if we want to isolate and find the arc length, we actually just have to do this. So remember, A is arc length, and R is radius. R is radius. Right? Okay. So let's go ahead and apply this formula. So we're looking for the arc length in this case. So A is equal to R times theta, so 2 times 6, 6, 12. Right? No questions. And for B, we're trying to find theta. So if we're gonna do A equals R in theta, so let's plug it in. So radius is 10. Arc length is 45, theta. So theta is equal to 45 over 10. Right? And you can go ahead and simplify that. So radius equals to 4.5 radians, right? And now let's do 3. 3, we're trying to find R. See how that plays out. So arc length is 28. Theta is 3.2 radians. Let's go ahead and do 28 divided by 3.2. I'm going to use a calculator, which is 8.75. So I want you guys to remember the units. So arc length is always going to be centimeters, and the theta is always going to be radians, and then the radius is always going to be centimeters as well. So let's go ahead and convert radians measure to a degree measure. So remember earlier I said pi radians. 1 pi radians is equal to 180 degrees. So now we're going to go ahead and isolate for, like, let's see. So if we want to convert to, okay, so right now we're trying to convert radian measures to degrees. Okay, so 1 pi radian, so 1 pi rad, so pi radians, this is 180 degrees. So 180 degrees, divide that by 6, it's going to be 30 degrees, right? So A is 30 degrees. And B, we're going to do, since 1 pi radian, so most of the time we don't write pi radian. We don't write pi rad. We just write pi, right? So we do 5 times 180 and 1 pi, 5 times 180 divided by 4. It's going to go ahead and give us 225 degrees. And finally, 2.2 radians. 2.2 pi radians. Let's go ahead and do that. So 1 pi radian is this, so 2.2. So we have 2.2 on the left. However, this one, it doesn't include pi. So if this doesn't include pi, what does this mean? What does this mean? This means that we have to do 2.2 divided by pi. Right? So if we have 2.2 on the left, 2.2 over pi. So that is 2.2 divided by pi. So it gives us a decimal, and then we times that by 180. That's going to give us 126 degrees. Nearest tenth, sorry. So 126.1 degrees. Right? So we always have to look at the value. If it gives you pi directly, okay, then do pi. If it doesn't give you pi, then don't do pi. So let's go ahead and go on the next question. Degrees to radians in exact form. Oh, why was this here? So let's go ahead and see. Find the exact measure of radian. So remember that pi radians equals to 180. So if we want 1 on the right, we'll have to divide both sides by this. So pi r over 180 is equal to 1. So we're gonna we're gonna actually, on the right, this is degrees. So what if we multiply the right by 45, and we have to multiply by the left at 45 as well. So 45 divided by 180, it's gonna be 0.25, otherwise known as 1 over 4. So now this actually simplifies to pi over 4. So since this r was the unit, so now we don't have to include it. So this is pi over 4 radians. So essentially we write pi over 4. And now since we know pi equals 180, right? So if pi equals 180, what 180 divided by what equals 60? 180 divided by 3. And now 210. Let's see how we can convert this to that. So 210, let's go ahead and divide that by 180. It's going to go ahead and give us 1.666666 repeated. So let's turn that into a fraction. So 1.16 should give us 7 over 6. So this should be 7 pi over 6. And let's just confirm. Let's do 7 times 180 divided by 6, which gives us 210, which is absolutely perfect. So we're done. And now we have a little bit more. So remember over here, I actually just I gave you the exact form. So I gave you pi over 4, pi over 6. I gave you a form like this. I didn't give you the calculation. I didn't calculate. I didn't enter the pi value because pi is a definite value, right? So let's go ahead and do this. We're now actually wanting the exact value. So what gives us 30? So it's pi over 6, right? We talked about this earlier. So now we actually have to do pi over 6, like literally enter pi over 6, and then we have to find an actual, value. So let's do pi over 6. So for me, I round that. It's going to give me 0.5 235, so I round that to 0.52, so equals 0.52 radians. Right, so that's an actual numeric value. And on the right, we have 240. So 240, we first change this, right? So we change it. So 240 divided by 180. That's going to give us 1.3333, otherwise known as 4 divided by 3. So this is going to be 4 pi over 3. And now let's actually literally just times 4 pi over 3. 4 times pi divided by 3. That's going to give us 4.18888, which rhymes to 4.19 radians. And therefore, we're done. So one big confusion that most people have is that they think this is an actual value, but no, it's not. These two are like units. So pi is equal to 180, right? So that's so please guys, the r is actually not a value. It's a unit. It's a measurement. And now let's move on to question 5. Wow, it keeps on showing up in the middle because it's so excited that we're gonna do this problem. So this question actually uses revolution, which I talked a little earlier. So a small electric motor turns at 2,000 revolutions per minute. So it spins so drastically fast that it goes, it's not too fast, but we're going 2,000 revolutions per minute. Express the angular velocity in radians per second. So before we start, let's go ahead and convert revolution into radians. So one revolution is 360 degrees, which is also equal to 2 pi. Right? So we have no problem over there. So if we 2 pi, we have to multiply that by 2,000 since it can spin 2,000 revolutions. It's gonna give you 4,000 pi. I love pi's per min. However, we need to times that by seconds. We need to do that by seconds. So how many seconds are there in a minute? So most of us should know there's 60 seconds in a minute. So we have to go ahead and divide that. So since this is 4,000 pi per min, we divide that by 60 seconds to see how many it can do per second. So let's go ahead and calculate. 4,000 divided by 60. It gives us 66 and 2 over 3 radians per second. So I can actually go ahead and get you a real value, but I'm not gonna do so. Wait, 4,000 divided by 60 seconds. And we forgot the pi, so this is what I meant to do. So that is how much we can do per minute, per second. However, since it's asking us to ask an exact answer, so right here, this is our exact answer. It's also asking us to give an approximate answer. So go ahead and calculate it out. So 4,000 times pi. And then we're going to divide it by 60. It's going to go ahead and give us 209.4. And therefore, we are done. So there's pretty much that's pretty much a simple lesson to get us started into the trigonometric functions by introducing a brand new unit. It's a little hard, it's a little confusing for some people. If you have any questions, please reach out to me and email me whatever you want to do. As well, your homework is on page 336 in the textbook linked in the description, or the textbook that I showed you on the first day of class. Alright, and that's it for this class.